So for today's video, I'm going to be showing you how to solve the two-phase simplex algorithm in Excel. So the first thing we're going to do is we're going to look at this greater than or equal to sign. This means that we're going to have to add a negative E1 and a positive A1 variable to it, which is going to be useful for when we're formulating our W function. So notice these two have smaller than or equal to signs, which means we're just going to add slack variables to them. So it's going to be x2 minus e1 plus a1 is equal to 3. And then we're going to add both of our slack variables to these constraints over here. So when formulating our W function, you need to keep in mind that if there were multiple variables or constraints that were greater than or equal to, we'd have to add them all together to formulate our W function. Luckily, we only have one variable or one constraint over here that is greater than or equal to. So we're going to take this and all we're going to do is we're going to remove the A1 and we're going to add a W. So it's going to be W plus x2 minus e1 equals 3. And this will serve as our W function right over here. The rest are slack variables, and our first constraint is going to stay the same, even though it is very similar to our W function. So let's look at actually formulating our tableau over here. So it's going to be all the same, x1, x2, s2, s3, e1, so on and so forth. So what you could have done is you could have added the e1 and the a1 variables at the start, but I didn't do that. I just added them at the end. S2, S3, it's just whatever you prefer. So a thing to keep in mind with our W function is that it's always a minimization problem with our W functions, always a min, which means we're going to be looking at our largest positive. Generally, if it's a maximization problem, we look at our largest negatives, but this is always a minimization problem. So, well, the W function is always a minimization problem, which means it's going to be our largest positive. So it's going to be this column over here. So our ratio is what we're going to need to find now. So it's going to be this divided by this, bam, drag. So when selecting our row, we're going to be looking for our smallest ratio, which is going to be 3. So let me just copy over here, paste, copy, paste. Oh, just remove this over here, like such. I'm just gonna no fill over here so we can just make it look less complicated. Okay, so this is gonna be our pivot column right over here. It's gonna be equals this divided by this, and we're gonna press F4 to lock it in. So it's gonna be this number divided by itself, the pivot column divided by itself, F4, bam, equals. And we're gonna just drag like this. Then we're gonna have equals this number, so the one in the same column that we selected, minus itself, F4 to lock in, multiplied by our pivot, 1. Drag and drag. Equals 1 F4 multiplied by 1. Every time it's just going to increment, so it's just going to be the one above it. Same thing. Drag, drag. Equals this minus this, F4 multiplied by 1, drag, drag, equals, bam, drag again, drag again. Perfect, so we can see that there are only negatives now, so if there are no positives, we know we're done with the W function, so we can actually just up and remove it. We're going to do the same for our A1 variables, or any A variables we have. So we're checking if they're basic or not. So to check if a variable is basic or not, you have to check if it has ones and zeros. If it doesn't, it's not basic. So if it's 0, -1, 0, 0, that's also non-basic because it's a -1. So if it doesn't include zeros and ones, then it's not then it's not basic. So this and we can only do it. So when we remove our W function, we can only do it for A variables. So this E variable isn't going to work, even though it's non-basic. We can't remove it because it's not an A variable. So we can remove this as well. Bam, just remove it. So if there was an A2 and was also non-basic, we'd remove it as well. Or an A3 or so on and so forth. Okay, so now it's just going to be the same thing. We're going to find the ratio, and now we're working with this function over here, this max function over here, our objective function. So we're now looking for our smallest negatives. So it's going to be negative 100. So this is going to be the column we're working with. So we take this right-hand side, divide by this. This is going to give us 0. So 3 divided by 0 is obviously impossible. So we just remove that. Now we're working with the smallest ratio, which is going to be this one right over here. And this is our selected column, so this is going to be our pivot. So now we just copy, okay. Let's move it upwards here. Perfect. So this actually doesn't exist anymore, but we're just going to keep it there for anyway. So this is going to be our column, this is going to be our row, this is our pivot. So equals, same stuff as always, F4, bam, drag. Now we're going to do equals, this one minus itself, F4 multiplied by our pivot column, our pivot element. I'm going to drag equals this minus this, F4 multiplied by our pivot, drag equals this minus this, F4 multiplied by our pivot. Perfect. So we're not working with this one over here, so this is irrelevant. And we're also not working with this, we just remove it over here. We can see we don't have any negative values in our objective function, which means we have found our optimal solution. So now we need to check for basic variables. So our x1 is basic, which means our x1 corresponds to this value over here. Our x2 is also basic, zeros and ones. It corresponds to this value over here. Our S2 variable is also basic, which means it corresponds to this value over here. Well, actually, I'm lying. Our x2 variable corresponds to this variable, this number right over here. Our x1 corresponds to this one. So it's going to be 2.8 as our x1, and our x2 is going to be 3. Our S2, however, is going to correspond to this value right over here. The rest of the values aren't basic, so they don't matter. And this is going to be our optimal solution. So we can check if we're correct or not. I'm going to pull up Desmos. So here we have our formulated graph. We can test for all of the points, but since I actually already know the answer, it's going to be this point right over here, 2.8 and 3. So we can see 2.8 and 3 corresponds to the values we got right over here, 3 and 2.8 and 3. And if you add them in our objective function over here, and if you substitute those values into this, you will find that it actually does correspond to 370. So that would be pretty much it for our two-phase simplex algorithm. If you would like me to make videos on other things related to linear programming or even other topics you might be interested in, just let me know down in the comments. And yeah, that's pretty much it for the two-phase simplex algorithm.